This is lesson 5, solving linear system by graphing. First thing that you do to solve the linear system by graphing, make sure both equations are in y equal to mx plus b form. So we need to isolate y in one side and the rest of the terms on the other side. And then graph both lines and then determine the points that they intersect. So, for example, we have two equations, y equal to 3x minus 1. This is already in y-intercept form. So, first thing you plot y-intercept. Y-intercept is negative 1. This one. And then slope is 3. Slope is 3, and you know that 3 equal to 3 over 1. So 3 over 1 equal to rise over run. So rise 3 and run 1. Let's start from y-intercept point and rise 3 points. 1, 2, 3, and run is 1. 1. You get your second point. We get our second point. Now we're gonna pass a line passing through these 2 points. And don't forget to put arrow like this. This is one equation. This is equation, this one, first one, done. And second one, again, y-intercept is 4. 1, 2, 3, 4. This point, and from that point the slope is negative 2. Negative 2 equal to negative 2 over 1. It rise 2 units. Negative 2, it means that come down 2 units. 1, because it is negative. 1, 2, and 1. It's going to be this point. And then let me show this with different color. You pass a line through these 2 points. Okay. And arrow at the beginning and end. And the answer for the question, the answer when you solve is the point of intersection. This is answer. And the answer is point x1, y2. This is 1 and 2. This is the answer. For next question, it is in y-intercept form. Remember, here make sure both equations are in y equal to mx plus b4. So this equation is incorrect for y equal to 2x minus 5, and second equation is 2x plus y equal to 1. We need to move this over to the other side. So we have y equal to 2x, because we have plus between. So when you move to the other side, this plus turn to negative. Negative 2x plus 1. This is 1 is y-intercept, and negative 2 is the slope. The slope equal to negative 2. You know that negative 2 is negative 2 over 1. Okay. Y-intercept is 1, this point, and from this point go negative 2, 1, rises 1, 2, and run is 1. These 2 points. And you pass a line going through these 2, maybe almost. Again, try again. Okay, don't forget to put arrow. And this one checked. We have done this one. Second one, equation is y equal to 2x minus 5. So it starts by showing minus 5 is this point, and y-intercept is 2. In this, I'm sorry, slope is 2. So it means that 2 units up, rise 1, 2, and run is 1 here. The reason is that y equal to y over 1. Rise 2, run 1. So it's going to be this point. And a line passing through these 2 points. You need to use ruler. And the point of intersection is the solution. I show solution with black. This is solution. Example 3. Determine whether the coordinate 2 and 1, x2, y1, is a solution of the linear system defined by this. If this is a solution, if you plug it into the equation, each of them, it should work. So I'm going to write the equation again. Y equal to 4x minus 7. This is the first equation. If you replace, put this points inside the equation. I'm talking about point 2 and 1. So instead of x, put 2. Instead of y, put 1. And then you put equal sign, and on top of that put question mark. One, two. And then write the rest. 2 times 4. We need to put this in bracket, minus 7. I want to see whether this works. It means that if 1 equal to the right side is equal to left side. If it is, then it work on this one, and then we try on the other equation. 1, is it equal to one? Is it equal to 4 times 2 is 8. 8 minus 7 is so 1. So this work. 1 equal to 8 minus 7 equal to 1. So this work on the first equation. Second time, we try to put this one, plug this one into the second equation. Second equation is y equal to negative 1 over 2 x plus 2. Okay. We are on this question, so I rewrite this, and y equal to negative 1 over 2x plus 2. I just rewrite this one, and then put this point into the equation and see whether it's really equal. So instead of y, put 1, and when you put equal sign, you need to put question mark on top, because we are not sure. And instead of x, put 2. 1 negative 1 over 2. Instead of x, put 2 plus 2. Is it left side equal to right side? We have 2 on numerator and 2 on the denominator. It is, this 2 is on numerator because it's like this. 2 and 2 cancel out each other. And then we have negative 1 over 1, which is negative 1. And the other term is 2. Is it equal to, question mark to the left side? Negative 1 plus 2 is 1. 1 is equal to 1. So it means it works. So it means that point 2 and 1 is a solution to the linear system, this linear system. Last example. Determine whether the coordinate -3, 5 is a solution to the linear system defined by this. Okay, I rewrite the equation. First equation is y equal to 1/3 x plus 5. And second equation is 4x plus 2y plus 4 equal to 0. Okay, and the points that we want to prove that its solution is 3 and 5. So one time plug this form into the first equation. Instead of x, put -3. And instead of y, put 5. And then put question mark because we are not sure. We have multiplication between. These two cancel out each other and we have negative sign, so it's going to be -1 plus 5. -1 plus 5 is 4, and on the left side we have 5. So 5 is not equal to left 4. So this is not a solution. It doesn't work on this because here imagine you have two lines. If this is the solution, okay, if it is the point of intersection is solution, this point belong to this line, also this point belong to this line, so it should work on both. So this is not a solution because it doesn't work on the first one. I don't bother myself to try the other one. Good luck, and it concludes lesson 5.